Voltaic cell. If you are Voltaic cell, first you must make sure you have two inert value. Two inert value means you have two electrode potential. For example, your zinc put into zinc solution 1 molar. 1 molar. Okay, no? And then you have second half cell. For example, copper put into copper solution 1 molar. 1 molar. And then you must connect it by the salt bridge. This one you connect salt bridge. Salt bridge you use saturated potassium nitrate. And then you have to measure the volt by measuring the potential difference using voltmeter. Alright, so this is the circuit. Circuit is for the transfer of electron. So no matter what, you must have two different half cells. For example, maybe some of the half cell is inside another half cell, then you have something like this. Remember this thing? And then they have different electrolyte, right? Where the outside is zinc in the zinc solution, and inside is the copper solution and copper. You studied like this before, right? You even studied a U-tube, right? They are all the same as long as you are connected. And then circuit is for the transfer of electron. Ions, you use the saturated solution or concentrate sulfuric acid, something like that. Alright, so we continue. So I will erase this thing. So always remember, a Voltaic cell, you start by chemical reaction to electrical energy. So we say chemical energy to electrical energy. So you start by chemical reaction. Zinc and copper, you look at the SEP value. They are all written in reduction form. Zinc is negative 0.76, the inert value, volt. And the copper, 2 positive, is positive 0.34, right? I already memorized it. So when you choose these two as a connector, how do you analyze? Your negative value here is a reducing agent that undergo oxidation. Zinc will be oxidized. And then this is a positive value. I use another color. Positive value. So this is an oxidizing agent that undergo reduction. So copper will become will be deposited as copper solid. Alright, so you say the copper electron become thicker and thicker, and the zinc electron become thinner and thinner. And then the blue color intensity become decreasing. Am I too fast? Huh? Not too fast? Huh? So you will know that the things undergo oxidation is anode. So you will start by anode. Anode, zinc solid becoming zinc 2 positive aqueous plus 2 electron. So inert value now is you reverse it, you become positive value. Am I too fast? Okay, continue. You have a cathode. Cathode, you always write a negative, I would say reduction reaction. A reduction reaction by copper aqueous plus 2 electron become, you look at here, I no longer write reversible. Over here, I write a reversible because this data is copied from the SEP value. Now, after you analyze, you know that this one undergo oxidation and that one undergo reduction. You need to write an exact error. Should not write any more reversible, understand? Okay, because this is spontaneous. Okay, now copper solid. Okay, so you copy the whole thing because this is this. So EMF of the cell, you can just directly copy 76 plus positive 0.34, you get positive 1.10 volt. So this is how you calculate. Now by adding it, or you can calculate like this: E naught of the cell equals to E naught of the cathode minus E naught of the anode. Okay, so cathode is what? Cathode undergo reduction, or cathode is this one. So this is positive 0.34 minus this is the negative 0.36. Why over here I still use negative? Or over here I already changed to positive? Because this one I write in this form. When I reverse it, my sign also reverse automatically. And so I add on. 已经转了的，你就加起来。你不要转了再减回去时哦， you back to the original。哦，所以错了。所以转了你加起来。If you haven't start with any equation, you just take the value directly like this. So you put things like this. This is mild substitution. Then over here you become like this. Depends. Depends how you answer. Sometimes you know that this is not a Voltaic cell, then you have to say E of reduction minus E oxidation for redox reaction. And you copy like that. Alright, continue. You must learn how to write an ionic equation. Now this is your ionic equation. Ionic equation is to cancel out the electron. This reaction just nice, 2 electron, 2 electron. You direct cancel, or else you have to times something and then cancel the electron, everything copy down. Alright, okay, then this one is zinc 2 positive, aqueous plus copper solid. Then you say, teacher, do I need to write physical stat? Yes, this is Form 6 A level. Because later you advance Nernst equation, you need physical stats. Right? So you need to write physical stats for this chapter. Previous thermochemistry and electrochemistry, you need to write physical stats. So this is how voltaic react. So which one is positive terminal, which one is negative terminal? Source of electron. When the electron come out from here, alright, like this is the source of electron come out, and then it is received over here, isn't it? So this is the positive terminal, this is the negative terminal. So negative electron is zinc, positive electron is what? Copper. Source of electron is negative terminal. And the source of electron will undergo oxidation because you start reaction first. Reaction followed by electron transfer. 所以出 electron 那个地方是碱。